There is a very basic question in horizontal axis wind turbines. Why the hub is turning? Apparently, the blades present an angle, the pitch angle, that seems to be, most of the time, at 0 degrees respect to their rotation plane. Looks like they present a maximum stopping plane to the flow of wind. How this angle produces a rotational movement of the blades? And why it looks like, is this the case of maximum power? An intuitive explanation can be visualized, knowing that the blades in a wind turbine, and the wings in an airplane, follow the same aerodynamic design principle. In the tutorial you can find this explanation. In the launcher, use the Some Practical Experiments menu, then press Suggested Experiments to present a tutorial with several items. Choose the one with title, Why the Blades in a Wind Turbine Turn? A new tutorial will show the item of reference. The figure presents a laminar flow, horizontal, from left to right. In the center it is shown the section of an airplane wing. This wing is firmly attached to the vertical walls, not shown, containing the airflow. This fixation is through a rod, perpendicular to the section of the wing, and represented by a circle, at the center. The dotted arrows represent the pressure, or depletion, exerted by the flow on each point of the wing's surface. These pressures are due to the deformation of the laminar flow, as it traverses the wing section. As we assume that the wing is a rigid body, adding all dotted arrow vectors, results in the red vector. And, is applied to the only support point, the rod. This red vector can be decomposed as we like. In this case, it is convenient to decompose it into two green vectors. One of them is pointing up, and labeled F lifting, the other one is pointing rigged, and is labeled F dragging. In this way, it is clear that the force pointing up is the one responsible of the sustentation of the airplane, while the other, pointing horizontally to the right, corresponds to the force that must be overcome by the airplane motors. Thus, this figure shows that the force applied by the airplane motors to the wing is transformed in a vertical substaining force. Now, look at the figure below. It presents the hub, and a blade. The blade can rotate around the axis that passes through the point where it is attached to the hub, and comes out of the paper. This is the angle of pitch. The hub can rotate too, so that the blade rotates in a plane perpendicular to the figure, and it passes through the horizontal line indicated by the black vector. This black vector corresponds to the incident wind on the edge of the blade, due to the rotation of the hub. This situation is totally similar to the previous one, with the airplane wing. The only difference is that the wind direction hitting the edge of the blade is the addition of two vectors. The horizontal black vector, due to the rotation of the hub, and the vertical blue vector, going downwards, that corresponds to the real wind hitting the rotational plane of the blades. Their addition results in the red vector. Therefore, similarly to the airplane wing, the result of the red vector wind applied to the blade produces a force on it, shown as the green vector. We decompose this force in two forces, the violet one, that is horizontal, going leftwards, and the light brown one, going downwards. The violet force is the one responsible of moving the hub, that can only turns. The light brown force is the force that must be counteracted bit the tower, and tries to bend it.